Overhead lines is a common way to distribute power in North America. So you'll find those distribution overhead lines in many places, in many cities in North America. Now, at a certain point, you need to connect the overhead lines to the underground cables, where these underground cables will go all the way until they reach the distribution transformers. And these distribution transformers, the voltage level will be stepped down from the primary voltage level, which is 13.8 kV, 12.47 kV, 11 kV, and other voltage levels, to the 110, 120 volt that is will be utilized by the customer. Now the question is how we connect the overhead lines with the underground cables. So what we have here, we have what we call the cable terminations. The cable termination is the connection point between the overhead lines and the underground cable. So what are their designs? What are their types? Why we need them? And other questions will be answered in the coming video. So please join me in this short video about cable terminations.
And let's talk about cable terminations. We have seen the cable termination in the previous video, which is basically a connection between the underground cables and the overhead lines. Also, we can use the cable termination when we connect the underground cables with a device like a transformer or a circuit breaker or other devices as well. Okay, so basically the cable termination is composed of, I would say, two main things: outer and inner parts. Now for the outer parts, you can see here the sheds, and here also you can see the sheds as well. Here is also the sheds. Okay, so these sheds for protection and to increase the creepage distance, but has nothing to do with the cable termination stress grading material, which is the main component of the cable termination, and we'll see why we need this stress grading material. Then the inner part of the cable termination, we have the stress grading material that we cannot see here. And when you look to these uh, photos, we cannot see the stress grading material. It is under the outer part of the cable termination. We answered two questions. First, why we need cable terminations and why we need the stress grading material of the cable termination. The second question is, what are the different types of the cable termination? So let's start with the first question, why there is a need for a cable termination. To understand this question, let's look for construction of the cable. So the cable basic materials is, we have the conductor here. This is the conductor. We have the insulation, which is mainly XLPE, cross-linked polyethylene, or could be any other polymer material. And we have this black material is the semiconductor layer. Okay, so that's the basic structure of any cable. So what's wrong if I take this cable here and connect it directly to the overhead line conductor? So this is our ACSR, aluminum conductor, steel reinforced conductor, and that's it. So why I have to worry about the stress grading material? Now here, this is a conductor, and this is a conductor, this is an insulation, and this is air. So we will have that tripling point, and I have a video about this tripling point, and it showed that this will be an area of a very high electrical stress that will lead to partial discharge. And if you look here now, of course, when I want to connect the underground cable with the overhead lines, I have to remove, basically, I have to remove the insulation, and I have to remove also the stress grading material so that there will be connections between the two. Now, when you zoom in this area, this is the XLPE, this is the conductor, and this is the semiconductor, the material here, the semicon, and this is the outer shell. This is the ground conductor. This is the ground conductor. Okay. Now, because this is a semiconductor material and this is a ground, so the potential here will be also zero. So this will be like a grounded end. Now, there's a high voltage here. Then you will have here a very, very high electrical stress. As I said, one way to look into it, this is a tripling point. Okay, so you will have here a very, very high electrical stress, and you can see that from the potential lines. So you can see here this area will have a very, very high electrical stress. Remember, always E is equal to dV by dx. So these are equipotential lines that we see them here, and you can see they are become very close to each other here. So it means that the electric field will be very, very, very high. Now, this is a small experiment we conducted here. We have here a 5 kV cable. So this is the XLPE. The conductor is, you cannot see it here, but it's at the far end here. And this is the semicon. And this is the ground conductor. So what we did here, we energized the cable and we used image intensifier to see the discharges. And we look here, this green part, these are partial discharges at this end here, starting here because of the very high electrical stress. So this is something that we have to reduce the electrical stress here because this eventually will cause a failure of the cable. So we need to use a stress grading material to ease the electrical stress, to reduce the electrical stress here, and then cover everything so that it will be protected from the environment. And these are the inner and the outer part of the cable termination. So how we do that, I will show you 3 different types of cable termination or stress grading material. The first one is the stress cone. So back here, this is the black layer here is your semi con material. Okay, this is your conductor here. This is your conductor, and this is your XLB. Now here, as we agreed, it is a very high electrical stress. So what we do here, we extend the insulation, but in a wider space or a wider area. So this will be your actually the insulating material. So you add and you have what a shape of a cone. So now you see here the electric field lines will follow now the electrical insulation. So they are apart from each other. And here you can see that the electrical stress has been reduced by using this type of capacitive grading. And this is by increasing the insulating material. This type of cable terminations is used in the distribution level. Now, if you want to use it for the transmission, this becomes very, very bulky. The cone becomes huge and it's not practical. So this is only used for distribution level cable termination. Another way of easing or reducing the electrical stress is to use what we call high dielectric constant, high permittivity material, or sometimes it's called high K material. Okay, how it works. Now, remember, this is the conductor, this is the XLBE, the insulation, and this is your high K material, and this is your semicon, this black line. Now, before this was air, nothing there. Now again, epsilon 1 E1 equal to epsilon 2 E2. So let's look to this zone, which is here, it was air, and here is XLBE. Okay, so let's say epsilon 1 E1 is the air, epsilon 2 E2 is in the insulation. So when it is air, epsilon 1 is much less than epsilon 2 because this is air, so this is the electric constant epsilon r is equal to 1. Here it is equal to 3 to 5. So the electric field here will be much higher than here. This is why we have high electrical stress when it was air. Now, when we add a material with a higher dielectric constant than the insulation itself, so this is why I call it high K. It's higher. Could be 10, 12, 13, something higher than this. So the electric field now in the stress grading material will be less than the electric field in the insulation. Okay, and you can see that here clearly. Again, these are the equipotential lines, and electric field is equal to dV by dx, of course, as a magnitude. Otherwise, there is a minus sign here. So you can see here that dV by dx in the stress grading is less than the dV by dx in the insulation. So we have here more stress in the insulation than in the stress grading material. And of course, the stress here is calculated because here it is XLB material. It has a very high withstand voltage, much higher than air, of course. So now you avoid any discharge here. The last method or the last type of stress grading is called resistive layer. Now here it is the same layer like this one, like this layer. Now we have here a different layer, but now this layer, instead of using high K material, we use resistive material. And this could be from carbon black or silicon carbide, or recently we are using zinc oxide. So you will have a resistive layer that will allow a current to flow. Okay, now how this works, how having a material that will allow a current to flow on this stress grading, for a small current, not a huge current, will allow us to reduce the field in this area. As you can see here, again, the electric field here is less than in the insulation. Now, if you look to this as an equivalent circuit where you have a voltage source, now I will draw an equivalent circuit without the stress grading material. So this is your voltage. There is a resistance or equivalent resistance between the insulation until you have the air. Now in the air, there is no, so this is R of your cable equivalent circuit. And this is an open circuit because we had air before that. So the whole voltage will be here. This is why we'll have a very high electrical stress across the air. This is a different way of looking for the same problem. Now, if I change this and I added another resistance R1, okay, then the voltage across the stress grading material will be following the voltage division. So voltage will be equal to the main voltage, let's say Vs here, Vs times R1 over R plus R1. So this voltage at the output will be less than the main stress voltage. Unlike when we have a sort of an open circuit, when we have no stress grading material, the whole voltage will be applied between these 2 points. So when we have a resistive type of stress grading material, we are reducing the stress actually by following, if you use the circuit theory to explain this, by using the voltage division. Now again, this type of material has a disadvantage, which is it allows a current. When it allows a current, there will be some heating, and sometimes there is an overheating that can damage the material. This is why we use a zinc oxide. Zinc oxide is a non-linear resistive material. Carbon black is a linear resistive material. So for this, it will have a different current densities or currents based on the electric field, because the relationship between the voltage and the current is non-linear. So that only at areas with when you have a very high electrical stress, then you will have a higher current to reduce the electrical stress. So this is an overview about the cable terminations, why we use them in whenever we have a connection between underground cable and overhead lines, or underground cables and any device, and what are some of the problems in the cable terminations.